12 blocks, and we're talking about a combined product that we're going to soon have available through OneRobot.org. The project will be the best place to get more information on the T-Bot. You can get information on just 12 blocks for your own propeller-based projects from 12blocks.com, which is Anna's site, or if you go to the OneRobot.org site today, as of this morning, Anna still had it going to his own site, so you can register there and we can send you more information about the robots when we have that ready. So that's the totality of my PowerPoint, all right? One slide PowerPoint. Today I'm not really talking so much about the robot itself as much as I'm going to do a demo of 12 blocks. So we'll build up a program from scratch, and so you can kind of see some of the new features that we're building, that Anna's built into 12 blocks lately. I think last year at this event there was a presentation on 12 blocks. If you saw it last year, you'll probably be quite amazed on how much progress has been made on it in the past year. So today's presentation, I'm going to be programming these robots in 12 blocks. I'm going to be doing everything wirelessly. We're using XP Wireless. And this is one of the more recent features that we've added to 12 blocks. The ability to do everything that I'm doing today, you can do with just the USB cord 2. 12 blocks is a graphical programming language that is specifically designed to target embedded systems. Specifically, right now it outputs spin, and at the end I'm talking about some of the directions that we're moving to target other platforms. Okay? So, by being a graphical programming language, it's ideal for teaching programming, but by the end of this I hope you also start to see that it could be beneficial either for adults who necessarily don't want to deal with text-based programming, or as you're doing larger, more complicated projects, it's very useful for being the highest level of your program to kind of give either for prototyping reasons or for program management. So all of our programs in 12 blocks start with a start block, you can see here. Can everybody kind of read that? I don't know how small it is in the back. You can't read it at all? All right. You can't read it in the front. All right. I don't know if I can zoom in any more. I don't know that I can. I can. I'll just try and. Is that any better? Okay. I will try and keep my program in the part where you can see. Okay, so we're going to start with a start block, and a start block in 12 blocks is just this represents one cog of execution. So every time I start a start block, that's another cog, okay? And the most basic program I think that we could write is just set an LED to a certain color. And so over on the part you can't see, here, on the side of it is where I'm pulling our categories of blocks. And so as I go through here, you can see I'm presented with different kinds of blocks based on that category. Okay? So, and then here is the actual block. And if I wanted a block, I would just drag it over. So it's very easy to get the blocks from your block library over into your program. Okay? So if I can pull this set LED block from the T-Bot library, and if this is going to be interesting. I'll show you this once and then I'll just do it for the rest of the time. Up here at the top I can select what device I have, so I can target the demo board, a couple iterations of the robot, and another robot here. So I'll select the proper robot. That's what tells 12 blocks what kind of code to generate, what base drivers to pull from, that kind of stuff. Here under port, I'm going to select what I want to use. In this case, I'm using XP. So down at the bottom, I have 4 robots available for me to select. So I'll select one of those robots, and now when I hit run, it will actually program one of those robots. and if a light turned red, I can actually see what's happening. So, okay, good. All right, so moving on, I can very easily change this to program one of the other robots, and I'll go through and maybe it's a multicolored LED. It may not be super red. These are prototypes still, please bear with the robot. Okay, so that is all right. It's not super exciting. As I want to add functionality to my program, like a repeat block, I can simply drag and copy blocks. I can copy blocks from my block library. I worked a lot with Nano in improving the user interface. If you've used a program like Scratch, which is very similar to this, but for programming like little computer animations or games, this is a very similar style of programming, but I think the user interface is really quite nice to use once you get used to it. So now I have a little program. I'm going to put it in. See if I can. At some point, I'm actually going to have to know what robot I'm programming. All right. So there we go. So now that red LED isn't working right very well. All right, good. Okay, so let's set the other ones aside for a little while. It'll be less confusing. And we'll stick with this robot for now. So I have a program here, and I like to use the multicolored LED to just kind of let me know that the programs are, that's my feedback, right? The program's running, that kind of stuff. But it'd be a lot more interesting if the robot was actually moving. So I'm going to start another stack and leave this diagnostic stack over here. And this is actually going to now create another cog. It's going to start another cog to run whatever code I put in that stack. We also have, of course, variables that we can define. And I'm going to define two variables for convenience. Yes, an actual, we're going to use a full propeller cog to execute. So these stacks will run in parallel, which is kind of cool because even at a very young age, kids can kind of understand that these are going to run, and they start to learn how to write parallel programs, which is very useful in an embedded system like a robot, without them really having to understand threads and all the other stuff that goes into that. So I'm going to create two variables called left wheel and right wheel. You don't really have to do anything more special to create a variable than just set it to a value somewhere in your program. And then I'm going to come to the motion section and drive based off of those variables. If you have a different hardware, you very likely would use the same block, and the driver, based on the device I selected, would actually implement the proper spin code. Okay, so I have a set left wheel to 0, set right wheel to 0, set motor to left wheel speed, right wheel speed. Okay? And we don't expect that to be very exciting since the value is 0. But now, one of the really cool things about 12 blocks is while it's running, my program is something that I can modify live. Specifically, right now, I can modify any constants. Okay, so if I just type in a number here, it's going to start moving. Let's see if I can keep it on the table for the entire presentation. All right, so just by changing this constant without reprogramming, without doing anything, the constant values immediately change. Live update. So that's a really handy feature where the program itself kind of becomes a interface into modifying the running program. If I needed to, there is, you can't see, but up at the top there's a stop button, which is really useful even in a wireless scenario. What it does is it literally loads a program in that stops the robot. Okay, so if the robot was going crazy, hopefully as long as the wireless part of the system is still working, you can very easily stop the robot from what it's doing. So that's interesting, but not really very useful. The next thing that we can do is we have what's called a user interface block. So this is going to take that idea one step further. So here I have a user interface block that I actually wrote using a plugin system. So if you're a programmer, you can actually write your own blocks, create your own definition for what a user interface block will be, and then 12 blocks can use that code. So this is my own code, not Anna's code. And what it's going to do is it's going to take my gamepad here, and you can see the values changing. You might not be able to read them, but the values on the user interface block change. Now, what we do is a user interface block basically maps something, in this case my gamepad, to a variable in my program. Okay? In this case, it's going to create a bunch of variables: x1, y1, x2, y2, buttons, point of view hat. All right? And whenever the input changes, that variable is going to change. And when 12 blocks does its magic, literally the running variable in the program will change. So this becomes very powerful very fast. I'm going to change one parameter so that the range of my variables is what I want. And now, instead of setting these to constant values, let's set them to those magic variables that the joystick is going to create. And I'm going to have to use both hands here. So now I can, so now when I hit run, the joystick is driving the robot. Now you can't really tell, but it's actually kind of driving backwards for me, where forward is backwards and backwards is forward. That's just a function of how this works. So of course I could fix it in my program just by changing this expression here, and now it should at least. That kind of change won't work live.